Dear friends, welcome to the new video. This video is about the refraction of light. The refraction of light it is a optical phenomena, and it involves the two mediums like air and water, air and glass, or whatsoever. So look at this diagram. This diagram. This diagram explains the phenomena of refraction of light. But before to proceed, kindly keep subscribing this channel. Now come back over here. Actually, here also involve the two mediums. Number one, air. This whole space, this whole place is filled up with the air, like the atmosphere. And this is the glass block or piece of the block, or it can be said to be, it might be a water also. It might be a transparent plastic or any substance like that. But here in this diagram, it is a block or slab of a glass, and the space over here, it is filled up with the air. Hence, two mediums are involved. One is the air from here to here, and the other one is the glass, or as I said in the beginning, or that is glass, transparent plastic, water, whatsoever. And air is a optically having the less density medium or less denser medium. On the other hand, glass is having the more density, or it is a more denser. Optically, glass is more denser. Water is also optically more denser, but glass is most denser in a way, we can say that. Now this is the ray of light, or these are the light waves. These are the light wave, and the light waves or the light ray falls at this point. This is the boundary of the two mediums. The glass is starting or beginning over here and goes down, and the air is finishing or ending along this line. It means two mediums are merging, like this is air and this is glass. So air is ending or beginning or finishing along this line, and the glass block is touching along this point and now along this line, and now the glass is extending downward. So this is the boundary of air and glass in this example. Now this is the light ray or the light waves, and this light wave or light ray is written over here. I means incident. I means incident ray. So it is a incident ray, and it strikes or falls at this point on the boundary of the air and the glass. And now this is the normal at the point of incidence, and normal is drawn to measure the angles. For example, in this example or in this figure, this normal is drawn. This normal is drawn to measure this angle I, or angle of incidence, which forms in the air. The angle of incidence is forming in the air. Now, the actual direction of propagation or the actual direction of traveling is this dotted line shows that if there were no piece of glass, then light will go straight along this path, along this is the original direction. But as it is a glass slab or the glass block, so light cannot move or cannot travel in the straight line. It cannot go in the straight line, rather than it will bend from the original direction. This is the original direction, and if I take away the glass, then the light will move or travel along this straight line. It is the original direction of traveling. It is the original direction of propagation. But as the glass is over here, if the water is over here or any transparent material is over here, then the light cannot travel in the original direction. It will bend toward the normal and come close to the normal. Number one, this is the one effect of refraction, that the light bends from the original path and close to the normal, and as well as the second effect is the wave contracts and smaller waves are formed. Look over here. Here is the this is the wavelength. Wavelength means length of one wave. Like if I draw the figure, this is the length of the wave from this point to this point. This is the wavelength. This is the wavelength. This is the wavelength. Length of one wave. So here the wavelength is greater or longest when the light is in the optically less denser medium or in the air. Waves are covering the larger distances, but when the light enters or travels in the optically more denser medium, in water, in glass, then the wave contract and wavelength decreases, wavelength changes, and the light bends from the original direction of propagation. This phenomena, when the light travels from one to another medium, then it bends from the original path of propagation and its wavelength is changing or changes. This phenomena is called refraction of light. And here it must be in mind that in here waves are longer, wavelength is greater, so light travels at greater distances, so the speed of light is greater. Let's say V1. V mean speed, and 1 mean speed in the first medium. So V1 mean the speed of light in the first medium, there is air, and it is a very common figure, and everybody knows that light travels in the air with this velocity. It travels or it covers the 3 into 10 raised to power 8 meter distance in every 1 second. But this is the speed of light in the air, 3 into 10 to the power 8. Now when the light enters from optically less denser medium into the more denser medium, then it bends towards the normal and the wavelength is decreased, but velocity of light is also decreased. It must be in mind, because here the waves are longer, they are traveling the larger distance, and here the waves are smaller, so they travel the smaller distance, and that's why the speed of light is decreased. Now V2, V is the speed of light in the second medium. Now how much it would be? This question mark shows that the speed of light, it may have any value. It depends upon the density of the medium. If it is water, then speed of light in the second medium will be something different, and if it is glass, then if glass is more denser than air or than water, so it would be something more or something else other than this. But speed of light in the air is 3 into 10 to the power 8. Hence, the phenomena of refraction is defined as when the light travels from one medium into another medium, then it bends from the original direction of propagation, and the wavelength of light is decreased or reduced, and the speed of light is also decreased. This phenomena is called refraction of light, and the same thing is written over here. When the light, how the refraction affects the light rays. So when the light travels from one medium into another medium, then the light bends from the original direction of propagation, like this. It is the original direction of propagation. And secondly, the wavelength of the light is decreased or changes whatsoever. Now the next topic is refractive index. This is the symbol, small m is the symbol for refractive index, and it is a very important parameter or the very important topic related to this topic, related to refraction of light. What is refractive index? So the refractive index is the number. It is a number and shows, or it is the measure of the refraction power, refractive ability of the material, like the refractive index of the glass. shows, or it is a measure of refraction power or refraction ability of the glass. Refractive index of water means the refraction power or refractive power of the glass, that how much glass can bend the light rays. So refractive index is in other words, in easy language, we can say that it shows the refraction power. Now how it is calculated? So for number one thing more, let me clear. This is the refracted ray. REF means refracted ray. Now how to calculate the refractive index of any material? So we find the sign. This is the SIN, means sign function, and it is discussed in the trigonometry. We call it sign. So we find the sine of angle of incidence, sine of angle of incidence, and the sine of angle of refraction. Hence, what is refractive index? Yeah, how the refractive index is defined? So we say that refractive index of any material is a ratio of sine of angle of incidence to the sine of angle of refraction. That is the formula to calculate the refractive index. If we put the value of angle of incidence like 10 degree, 20, 30, whatsoever over here, and the angle of refraction over here, then find the sine of that angle and sine of angle of refraction, and then divide this value to this value. We will get the number, which number is the refractive index of this medium. Now let us explain it with a question. This is the question, and in this question, it is the same figure. It is a glass slab. These are the light rays, and it is falling at the angle of 45 degree. So 45 degree is the angle of, this is the angle of incidence. It is the angle of incidence. And similarly, N is the refractive index of the glass, but angle of refraction is not given. We are required to calculate or find out what is the angle of refraction, 10 degree, 20 degree, or whatsoever. So this is the angle of refraction. This is the refracted ray. REF means refracted ray, and it is IN means incident ray. IN means incident ray. This is. Now how to calculate the angle of refraction? So we apply the formula of refractive index of the material, which is defined as, what is refractive index? The refractive index is defined as, it is the ratio of sine of angle of incidence to the sine of angle of refraction. So now put the values. What is the angle I, or what is the angle of incidence? Which is 45 degree. Angle I, angle of incidence 45 degree. We put this 45 degree over here, and hence angle I is equal to 45 degree. We have put it. What is the value of angle R? We don't know the value of angle of refraction. At which angle light refract? We don't know that. And in this question, we have to find out the value of angle of refraction. So we will place the symbol as it is. What is the value of angle of, what is the value of refractive index of this material? So it is given, and 1.5. So the refractive index which is given, glass box refractive index, put the value of N, or put the value of refractive index 1.5. Now come over here, cross multiply, bring 1.5 over here and bring sine of angle of refraction over here, and now this is 1.5, bring over here, and sine of angle of refraction over here. Look, hence the equation changes from here to this shape. Now, what is the value of sine of 45 degree angle? So press the sine function button on the calculator and then press 45 degree. Then the calculator will show sine 45 is equal to 0.707. Put this 0.707 over here, sine 45, place of sine 45, and then sine 45 value comes over here, 0.707, and write down, leave 1.5 as it is. Now divide 0.707 by 1.5. Then we say that the answer comes around 0.47. 0.47, and hence sine of angle of refraction is equal to 0.47. Now once again let me say that this is sine function, but this is sine inverse function. When the sine changes its side and it is taken from left side to the right side, then this minus 1 appears on the sine function. And this sine function, this sine minus 1 is called sine inverse function. So press the shift button on your calculator, and after pressing the shift button, press the sine inverse function button and then 0.47. The answer will be displayed by the calculator that the angle of refraction is 28 degree, and it means light enters at the 45 degree and then it bends from the original path of propagation. Let's say this is the original path of propagation. This is the original path of propagation, but light, due to the presence of this glass, light cannot travel on its own original direction and it bends toward the normal, and hence it formed the angle of 28 degree. Hence the angle of refraction is 28 degree. Hopefully you will find this video helpful. Kindly subscribe my channel.